Okay. So now, for photochemistry, okay, because this lecture slide has been prepared mostly by Dr. Ili, and I just add some bits, okay. So prior knowledge, okay, maybe, which is right now, some of you are taking atomic spectroscopy, which is good. And some of you has done the subject probably last semester or last year. I'm not so sure about the structure. Okay, so it's good for you to recall back actually the fundamental of the spectroscopy, which is the electron excitation, relaxation, photon emission, absorption. So I hope that you can recall back all this, okay, where you learn this in both atomic spectroscopy, for example, in UV visible, in fluorescent spectroscopy, and also you learn about this in AES, ICP AES, okay, and some of it are covered also in molecular spectroscopy. Okay, so it's good to revise back on the equations, for example, as Einstein equation involving energy equal to Planck constant times speed of light squared, E equal to H psi, frequency of the wavelength, Planck constant times frequency. And good to revise the Jablonski diagram. Helmi, do you remember Jablonski diagram?
No, bro.
Okay. Because Jablonski diagram can explain about the electron excitation, fluorescence, photon production, which is related to photochemistry. Okay, you learn about energy of chemical reaction, which is enthalpy. I hope that you remember your undergraduate's chemistry about enthalpy. So enthalpy is about heat, right? When the chemical reaction needs to happen, they requires energy. So when you are talking about thermochemical equation, you are talking about heats that needs to be supplied to the chemical, to the reactants, so that it reacts producing products. Okay, that's what you have learned. You should learn before. Okay, so now instead of heat, normal heat, you heat it up, raise the temperature. Photochemistry is about using energy from light. Okay, that's why it is photon. Yeah? Energy from light for the chemical reaction to happen. So instead of heat, by increasing the temperature, we are now focusing on photon, which is energy in the form of light, so that the chemical reaction can happen. So I need you to get that idea first, because without that, you might confuse what are we talking about. Okay, right. So I'm going to recall back what you should have learned in atomic spectroscopy. All right. So, and know what is photon, because in photochemistry, this is the main reactant. Okay, so in any chemical reaction, we have reactant and we have product. Okay, so photon is one of the reactant, but it does not being consumed. Because remember the first, what do you call, I forgot. Energy cannot be created. Energy cannot be destroyed. It can only be changed into another form. Okay, so you remember about your kinetic energy, potential energy. So according to first law of thermodynamics, okay, energy cannot be created. Energy cannot be destroyed, but it can only change form. Okay, so photon is a reactant in a chemical reaction, photochemical reaction. It's a reactant, but it will not be consumed. It will only change certain forms. Yeah. So let's understand this first. What is a photon? So just now we are talking about energy provided for chemical reaction. So instead of heat, we are talking about energy in the form of light, which is known as photon. Okay, so this one should be covered during actually your undergraduate's chemistry. So let's look at it. Okay, a photon is a piece of energy, has no mass. Actually, they have mass. Okay, but it has some mass, but I don't know whether we can say significant or not, but it has. Move at the speed of light, okay? Acts like a particle and a wave, okay? Particle and wave, okay? So the energy of a photon is quantized, right? So the easiest example is the sun. So when like we have this heat wave for the past 3 weeks, 4 weeks, I think this heat wave, so the sunlight is radiating us with all this UV and visible light with certain wavelength. So we are receiving those lights and heats, and we are sweating. Okay, there's a lot of biochemical reaction happening in our body. So there are a few words, there are a few terms from here for you to understand. Yeah, I don't know whether you still remember the mechanic, the classic mechanic and the quantum mechanic. What's the biggest difference? If you can answer, anyone? Anyone? Shalini, do you still remember? Hello? Anyone? I'm not asking a very complicated question. What is the biggest difference about classical mechanics and quantum mechanics? But this is year 1 undergraduate. All right. Asma, do you still remember, Asma?
Maybe in terms of the size of it, the size of the for the classical, maybe they are more like macro, and then for the quantum, it's more to like subatomic particles thing.
Right. Okay. So when we talk about you have hit some parts. The most important, because we are talking about photon, is about the characteristic of light itself. Okay. So the characteristic of light is related to electron as well. Okay. So in classical mechanic, they view, I mean, before quantum mechanics comes, this is very simple. It's a lot more than that. Yeah, it's a lot deeper than that. They view that photon is like a particle. Okay, meaning that you can imagine photon as a ball. Okay, so if you throw the ball, it will hit the wall, for example. Okay, so when you throw the ball, it hit the wall, you can see one pattern, which is where the ball hits the wall. So that is the characteristic of particle. But when they do experiment, it does not behave like that. When they release the photon, okay, it has different characteristic. I mean, the outcome does not like what they expect. So when quantum mechanics is discovered, not to say discovered, evolved into quantum mechanics. Now they understand that photon, yeah, electron, because it is the same thing in this case, is actually behave as particle just like something that have mass, okay, and also wave. Okay, so that's why we have electron duality characteristic. Electron or photon has this characteristic of particle and characteristic of wave. So when we're talking about wave, it has certain wavelength, it has energy, it has all the characteristic of wave. So you can imagine about wave at the sea, okay, how they have constructive interference, destructive interference. So that is the characteristic of photon. Okay, so I'm not going to, detail, but you need to recall that. Yeah, and then due to that, yeah, very important to understand quantization of energy. Again, I would like to ask anyone can remember. Quantization. It's okay if it is wrong. Sajita, do you remember?
Uh, Probably something that's not continuous, but I don't remember the real fine details, Prof.
Yes, okay, you got a word, okay. It's quantized, it's not continuous, yeah. All right. So let's look at what does it mean. Okay, all this because photon is the main ingredient or the main reactant in photochemical reaction. So you need to know about photon. Okay, let's look at if I don't have it. Okay. What Sajita said just now is something that you should learn in your atomic spectroscopy. Meaning that if you look at here, the energy of photon is quantized. Meaning that if you want to trigger a chemical reaction, remember, if you want to trigger or if you want to start a chemical reaction, a specific energy has to be provided. Okay, a specific energy has to be provided. If the energy level is not achieved, then the chemical reaction will not happen. Okay, for example, if the chemical reaction requires 30 kilojoule, for example, okay, 30 kilojoule. So if you keep supplying 20 kilojoule, the chemical reaction will not happen. So that is quantization, meaning that it is very specific energy required for that reaction because we are talking about photochemical reaction. So it's very specific and it has to surpass, okay, the value of the energy of the reaction. If not, then the reaction will not happen. So if you remember I forgot. I don't have it in my slides. It's okay. If something I forgot, then if it is not in front of my eyes, then it's difficult for me to explain. But the energy of reaction is very specific. And if you don't achieve the energy level, then you cannot have the reactant reacting as expected. Okay. So enough of the understanding about the photon. So in photochemistry, of course, when we talk about biology, it's also related to chemistry because it's actually carbon, hydrogen is the same thing. Okay, so biochemistry, chemistry, biology, they actually transcend boundaries. Okay, so in the context of green chemistry, photons are considered as reagents, okay, or reactants, because it can drive chemical reaction without directly participating in the reaction process. Okay, so remember about because it is energy, energy cannot be created, energy cannot be destroyed. It can only change from one form to another form. So photon is energy. It can get involved in the biochemical reaction, but it will not be consumed, okay, without directly participating. Just like when you do acid-base reaction, the acid and base are consumed, producing water, right? Water and salt. So it is no longer acid, it's no longer base, it's water and salt. But photon, when it's involved, but it is not directly, it will not change form into another product, okay? Because it's energy, according to first law of thermodynamic. So photons provide energy needed to initiate or accelerate the reaction by interacting with the reactants or catalysts involved, okay? All right, photons are acceleration reagent in which light energy is absorbed. Okay, this is what photon is, and this is how photon involve in photochemical reaction. So these are example of photochemical reaction, which is photocatalyst. There are others, we'll introduce more application for solar energy. So this is only a small part we will discuss. So remember about the things that I mentioned that you should know by now, the term excitation and emission, because you have covered it in atomic spectroscopy, but you might forgot. Okay, but you need to know about this. So when the molecules or compounds, okay, is bombarded with certain amount of photon, okay, bombarded certain amount of photon, okay, if the energy is exact or accurate, what is the right term? If the energy is correct, okay, as I mentioned just now, if it is needed 30 kilojoule, then the energy of the photon that is provided should be 30 kilojoule. If you provide 25 kilojoule, then the excitation of the electron in that molecule will not happen. Okay. Even though you give continuously 25 kilojoule, nothing will happen. It has to be exact 30 kilojoule. So that is quantization of energy, quantization of photon. Okay, let's say you give the right energy, which is 30 kilojoule, then the molecule that will be excited. The right way to say is the electron in the molecule. The electron in the molecule is excited. So this is the excitation. So the electron will move or excited from, this is actually orbitals. I hope that you remember orbitals. Energy level, lower energy level to higher energy level. Okay, so this is something quite common. When receive a specific amount of energy, then it will be excited to higher level. Okay, so the other one that can happen is once it is at certain level of higher energy, what happened is, of course, it needs to come down. So the relaxation process happen. So there are many process that can happen. It can, okay, let me show you the Jablonski diagram. Okay, so this is other way. So this is something that I don't have in this diagram. So the electron can relax straight to the ground level. Okay, from the, yeah, probably you remember n equal to 1 and n equal to 2, the orbital. So the electron can go straight to the ground, releasing, okay, that's what we call emission of the energy. The same amount of energy received, okay, when it goes down, the same difference, then it should be emitting the same amount of energy when going down to the lower level of energy level. Okay, so there is excitation and emission. But then this is what happening in atomic spectroscopy. You have absorption, okay, and some also we can measure emission. Okay, so we have emission spectroscopy, we have absorption spectroscopy, remember? Okay, and we can also have fluorescence. So what is the difference between fluorescence and just UV or visible region? Is there is inter-system crossing. Okay, I'm not going to, discuss back your atomic spectroscopy because this is something that you have learned. Okay, so instead of going back straight away to the ground level, you can see that it has certain movement, okay, here, and going down, you can see that the energy is not the same as energy being absorbed here because it has lost some energy here. So this is how you get fluorescence. So I'm not going to revise back your fluorescence, but this is the theory of when we talk about photon in photochemistry. Okay. All right. Again, this is easier for you to understand. Excitation of electron due to the photon exciting the electron. And then when it goes down, it should release the same amount of photon, okay, which is the energy. Right, so enough of that. So this first law of photochemistry and the second law of photochemistry that states that the light must be absorbed by photochemistry for photochemistry to occur with an appropriate. Actually, appropriate is not the right word. It should be specific. Okay, specific wavelength and energy. So meaning that in order for photochemical reaction to happen, it should be, the light given should be specific. Okay, if not, then the photochemical reaction will not happen. So the second law of photochemistry states that for each photon of light absorbed by chemical system, only one molecule is activated. Yeah, for a photochemical reaction. All right, so this one, because I mean, this has been studied before, so we just accept it. So these two laws. So if no photon is absorbed by the system, no photochemical change will occur, right? Okay. So this is the calculation of how we can calculate the energy of the photon. So this is Einstein equation. So E stands for the energy of photon. So we can calculate by considering Planck constant times the frequency of the photon. Okay, so remember photon behave like a particle as well as behave like wavelength, behave like wave. So it has frequency, it has wavelength. Whereas if anything that only behave like particles, okay, they don't have these, they only have mass, okay. They do have wavelength, but it is insignificant, okay. So if you try to imagine you have electron, you have a ball, a tennis ball, okay. So the tennis ball is a particle, whereas electron is a particle and also has a characteristic of wave. So when we talk about characteristic of wave, we are talking about the electron has certain frequency, has certain wavelength. And this is how we can calculate the energy given by the photon. So photon participate by interacting with molecules and exciting them to higher energy states. So this is what happened in the photochemical reaction. It does not like behave like solvent. It does not behave like giving out electron or whatsoever, but it makes it excite them to higher energy states, make the molecule more reactive and capable of undergoing chemical change. And photochemical reaction can be in different phases, solid, liquid, and gas. Yeah. So most chemical reaction, we usually focus on liquid and gas, but photo can also happen in solid. Okay, it's already 6:40, right? So energy source of reaction, this is just somehow the photochemical reaction happens. So photon carries energy that can be absorbed by molecule. So longer wavelength, lower energy, shorter wavelength, higher energy. Okay. What happens is once the molecules absorb the photon, the molecule may become excited. Just like I mentioned, the electron will be excited to higher level energy. Okay, and right, make the molecule more reactive and capable of doing the chemical reaction, like bond breaking, bond formation, because that is what is happening in chemical reaction. You have bond breaking and you have bond formation. Yeah. And there are also some terms talking about photodissociation. Okay. So photodissociation, if you look at example, you have a chlorine molecule, okay, with the photon, okay. This is E equal to H psi, which is energy required, supplied by proton. We can split this molecule into two chlorine radicals. Okay, so as you can see, it is not a reactant like A and plus B equal getting product of C or D, but this is like dissociation only of the molecule into radicals. So radicals is not anion, yeah. So radicals is just excited atom. They are not ions. Yeah? Radicals are excited atoms. And photon also can be a catalyst. Okay, so you have learned catalyst with Dr. Halim. So photon is a catalyst. An example of photon involved as a catalyst is in photosynthesis. So I think everybody knows about photosynthesis. So in photosynthesis, photons provide the energy necessary to convert CO2. Yeah, all right. So these are examples lah. Yeah, for just a moment. Photodissociation, photoredox reaction, photosubstitution. So a lot of, you can see that all here, the H psi is actually representing the photon. So key factors, okay, just a few minutes more. What are the most important in when we're looking at photochemical reaction? So wavelength of the light, because now the energy given is not heat, it's light. So the energy of photon depends on its wavelength. As I mentioned just now, longer wavelength, lower energy, shorter wavelength, higher energy. So that is the wave with the wavelength. Intensity of light means that how much, okay? So let's say that photons has 20 kilojoules of energy. So one photon, are you providing 10 photons or 20 photons? Okay, so let's say according to the rules just now, one photon, one molecule. So according to the law of the photochemistry just now, one photon, one molecule. So intensity of light will give you how much reaction will happen. Okay, wavelength of light give you the guarantee whether the photochemical reaction will happen because it is quantized. So if it is not the right energy, it won't happen. Even how many photons you provide, it will not happen. But once you surpass the value of the right energy, then the intensity will give you the quantity, how much molecules now can be converted into the products or any other, probably what depends on what kind of reaction, whether you have photodissociation or just chemical reaction as usual. So this will give you the how much after you have passed the level of energy. Okay, and only molecules that can absorb specific wavelength of light undergo photochemical reaction. So this is very important because not all compound can absorb photon. Okay, so so the characteristic is about conjugated bond. So we'll try to show you what is conjugated. I hope that you remember. So not all chemicals, compound can absorb photon. Okay, remember that. And presence of photocatalyst, of course, if you have a catalyst, then the reaction will be more optimized. Okay, all right. Right. So one example is very important example is photosynthesis. Yeah, very important because this provide food. Okay, so plants help us provide oxygen and we also get food from them. So everything starts from glucose, we get carbohydrates, we get all sorts of things that we can eat. Yeah? So plants, this is how plants help us. So please do think about plants. So the reaction, the reactant is CO2, H2O. This is something that we have learned in primary schools, that plants will consume CO2 and H2O and needs light from the sun to produce glucose and oxygen. So these two are great things that we need forever and ever. But some people say that we can synthetically do this, yeah, because instead of getting this photon from sun, we can have UV light produce, giving out the right wavelength so that we can get food, glucose, and production of oxygen. Okay, so I think this one is one of the most important photochemical reaction in this world, which is the photosynthesis. So I think that's it. We need to take a break, especially most of you just arrived or probably on the way back to your home. So, yeah, photography, I don't want to discuss because, you know, people are no longer, unless you're a professional, you know, doing photo shoots where you generate your own photos, but now it's all digital. All right, we stop here and then we continue at 8 o'clock. Yeah, everybody have a nice break.
Thank you,
Right.
Doctor.
All right.
Okay, bro.
All right. Okay. So I just want to introduce some real life example related to photosynthesis. Yeah. So this is Carbotech. This is local company, Malaysian company, and pioneered by UPM researcher. If you don't know, this is a startup before, but now they are turning into SME, I suppose, by Professor Suraya from Department of Chemical Engineering. So it's all about chemistry. So we talk about photosynthesis, right? So if you remember the reaction just now, CO2 plus water plus photon, okay, you can get glucose and oxygen. Yeah. So, of course, photosynthesis is very important. As we know, as I mentioned, this is one of the most important in the world because we really need it. We need the plants to supply us food. Okay, so plants need to do the photosynthesis. Apart from plants need to have fertilizers. Okay, remember, in order for plants or for soil to be healthy, they need fertilizers. So we're not talking about fertilizer today. We are talking about how the plants can enhance their photosynthesis. This is related to us. Why? Because if we look at here, okay, so this is the reaction happening in the cell. Usually is happening in the mitochondria. Yeah. Probably you can search the word mitochondria is where the reaction, the ATP, whatever biochemical reaction happens in the cell. Okay. So chlorophyll is the most important. Okay. The pigment, the chemical compound in the plants that absorb the light, that absorb the photon. Okay, so as you know, chlorophyll, we are really get used to the chlorophyll is green, but of course there are other colors like purple color. So chlorophyll, they have alpha and beta. So this chlorophyll is the compound that can absorb the photon, well, from sunlight or from artificial light. Okay, so remember about the statement just now in one of the slides that not all compound can absorb photon. There are certain characteristics of the chemical compound that can absorb photon. So chlorophyll is the most important in plants because it can absorb photon from sunlight or artificial light. Okay, so these Carbotex, okay, what they did is they produce material called carbon dots. Okay, it is made from carbon, that's why the name is carbon dots. And this carbon dots behavior is it enhances the absorption of the photon. So remember, photon is needed for the photosynthesis reaction. So with the addition of carbon dots, it enhances the absorption of the energy, and therefore the photosynthesis process is enhanced. So if the photosynthesis process is enhanced, of course, the production of fruits, the production of plants, the productions of flowers, they are all getting better. So carbon dots are tiny carbon fragments. So some of you might have heard what is carbon dots, quantum dots. Quantum dots usually they are talking about metal oxides, semiconductors. But carbon dots, they are more biological friendly because they are made of carbons. Yeah? So it's a tiny nano-sized particles of carbon, okay, being exploited for their potential to enhance plants photosynthesis. So I mentioned just now that it helps to absorb, enhance the absorption of photon from sunlight or artificial lights. Okay, by interacting with chloroplasts, okay, chloroplasts, carbon dots can improve light absorption and electron transfer. Of course, once you have the photon, then the molecule will be excited, then the chemical reaction become more enhanced, ultimately boosting the efficiency of photosynthesis. So it is not that difficult to produce carbon dots, and the application is not also rocket science. You just spray the the plants with the carbon dots at the right time, because it's during the photosynthesis time. Okay, we know that plants do the photosynthesis early in the morning and respiration at night. So yeah, so we have to optimize the application of carbon dots. So this can lead to increased plant growth, shortened crop cycles, and potentially higher yields. Okay, so Carbotech has used this photochemical concept in their technology, okay, by adding carbon dots, which enhance the absorption of photon. Okay, so naturally, plants have chlorophyll to absorb the photon, but now by adding these carbon dots, it absorbs more, and once it absorbs more, we have better product out of that plants, better leaves, better fruits, and better flowers, and therefore the plantations are getting more with higher yields. So this is seems like a very simple technology, but it works. Okay, so Carbotech has expand to the Southeast Asia, and they're getting recognized. Yeah. So yeah, it's not always in the lab. Yeah? Chemistry it does not always like everything is in the lab, but a simple chemistry applied, and you can see the outcome. So this is another photochemistry application. So what happened here is the production of ozone. So ozone is O3, okay? So photon can produce ozone, okay, from oxygen. So ozone, O3, is generated by the reaction of oxygen gas with this atomic oxygen, okay, with the help of photon, right? So what is the usage of ozone? We can use this for cleaning up. Yeah? So it can be used as a cleaning application, right? So there's a lot of other reactions involved. Photon. So this is silver chloride. We can dissociate the argentum and chlorine, as well as argentum bromide. Okay, and we can also dissociate, degrade nitrogen dioxide to nitrogen monoxide and oxygen by the help of this photon. So this is an example of photochemical reaction example. Yeah. Right. So photodegradation. Photodegradation, mostly we use it to break down organic contaminants. Okay, so let's say we have the problem of organic waste, organic compound, volatile organic compound, okay, in the water, for example. Then how do we remove the contaminants? Well, most of the time, many people remove it by adsorption. We apply, or we use polymers or natural products or activated carbons to clean up the water, for example. Okay, but we can also photodegrade the organic contaminants. Okay, so we can clean the water from VOC or any other organic compounds, unwanted one, okay, and convert it into CO2 plus H2O. So this is another application of photochemical. Okay, you can use UV or solar lights, okay, and that photon can trigger the conversion of all the organic contaminants, okay, and then producing harmless, considered harmless CO2 H2O. So from harmful to harmless by photodegradation. So this is the theory of how the photo can degrade the organic contaminants into CO2 and H2O. So I'm not well versed in semiconductor. It's about valence band and conduction band. So you can see that H2O, the electron is excited to the conduction band. Okay, I'm not going to discuss all this in detail because this is actually the expertise of Dr. Halim. Yeah? He do a lot of photo degradation. All right, so if you want to do more, you can discuss with him. Yeah, but this is one of the application of photochemical. So this is example of photocatalyst, okay, used in photo degradation. Okay, so one of it is TiO2, titanium dioxide. Okay, because of the semiconductor characteristic of the titanium oxide, so it can have this separation of his what they call it. Electron and holes. Yeah, H is not H plus, it's holes. So I've actually forgot about the theory of this semiconductor, but it can convert. It can convert this VOC, okay, or organic contaminants into the final harmless product, which is CO2 and H2O. Okay, so this is how it works. Yeah, you need lights or photon, and you need a photocatalyst, and the harmful substance can be photodegrade into harmless. Yeah, right. So the last one of photochemical application that I would like to introduce to you. So remember that we have discussed photosynthesis, the production of ozone or any other chemical reaction that involve photon as well, and photocatalysts that can convert harmful chemical into harmless, which is CO2 and H2O. And the last one is photodynamic. There's a lot of others, but I just want to focus on these four. So photodynamic therapy is being used in cancer treatment. Okay, so this is using photon, which is light, okay? And we need to have this, what we call as photosensitizer. Okay, I will explain to you. I will give you what is the example of photosensitizer. So when we have photosensitizer, okay, let me show you the example. All right, so this is an example of photosensitizer, porphyrin compound. And just like the synthesis just now, photosynthesis, chlorophyll is one of the sensitizer, photosensitizer. There are certain dyes that can be photosensitizers as well, and other molecules like carbon dots just now. So carbon dots are photosensitizers. They behave a bit of like semiconductors. Okay, they react to photon and they react to lights. Okay, so but I'm going to discuss why porphyrins and chlorophylls, they are considered photosensitizers, meaning that they do respond to photos and lights. As I mentioned just now, not all compounds can be under photochemical reaction. So the most important characteristic that I think you know, because you should learn this in molecular spectroscopy, that it needs to have aromatic ring, usually, and it has conjugated electron. So this is conjugated electron, double bond. What does it mean by conjugated electron? Anyone? Let's recall your organic chemistry. Anyone? What is conjugated? Tiffany? Can you give your view, Tiffany? Or is somewhere in the library?
I'm not sure, Prof.
Okay. So if you remember the word conjugated, the electron is what we call as localized. Yeah. What happened here is this electron can form double bond with this, or with, meaning that the double bond can move. Yeah, that's why electron is considered delocalized electron. This is what we call as delocalized electron. It is, you learn it in your organic chemistry. When we have this conjugated means that you have the double bond, okay, space with single bond, and you have another double bond. So this is what we call as conjugated. Yeah. So this conjugated means that the electron can in simple words, can jump. It is delocalized electron. Okay, please do search what is delocalized electron. So when the compound has this characteristic, has aromatic and delocalized electron, it can become photosensitizers. Why? Because the electron here can be excited. But if you have single bond, all single bond, no double bond at all, then the compound is not applicable in photochemical reaction. Okay, when you have all single bond. Okay, so when you learn about molecular spectroscopy, you learn about chromogen. Okay, what types of compound that can behave like chromogen, which is sensitive in UV wavelength, UV range, and some can behave in fluorescence range. So that is related to the chemical structure of the compound. Yeah. So I believe that chlorophylls also have this compounds. Let's do. I think I have the chlorophylls chemical structure. Yeah, I think this is it. But I'm not so sure, but I think this is the one. So you can see the conjugated, okay, delocalized electron. Okay, so let's go back to the photodynamic therapy. It is called photodynamic therapy. So when the photosensitizer is absorb photon, okay, what happens is it leads to generation of reactive oxygen species called ROS. Okay, so this one, okay, from the oxygen, just O2, it can produce reactive oxygen species. And you can click this link at your own time. Okay, listen to a lecture to this specifically of photodynamic therapy in cancer treatment. Okay, so with this reactive oxygen species, it can kill the cell, the cancer cell. Okay, so research has been done in terms of the cytotoxicity, meaning that how good that it can kill cancer cell. So I don't know how advanced it is. I don't have the time to study in detail, but this is the photochemical application in cancer treatment. So the same concept like photosynthesis, you need a photosensitizer. So in plants, they have chlorophyll, and the chlorophyll will absorb photon and make reaction to produce oxygen and glucose. But in this case, in photodynamic therapy, the photosensitizer will be excited and it triggers the production of ROS from O2, which kill the the cell, the cancer cell, right? So this is a bit detailed, okay, of what happened in the pathway of producing ROS just now. So this is the photosensitizer, and this is the photon, okay, using laser. So the light from laser give out certain energy, a photon, and then the photosensitizer will be excited into a higher state, okay? So, if you understand, just to mention to you, the singlet state and the triplet state, yeah? So if it's just a normal excitation and relaxation, it does not involve intersystem crossing. So these two, you have the same spin, okay? The same spin set, okay? I hope that you remember the quantum numbers. The main orbital, the suborbital, and the third one is remember the L, S, okay, orbital. And then you have the spin, okay? So the electron the spin has to be paired, clockwise, anti-clockwise in the same orbital. You cannot have the same spin in the same orbital, okay? That is first year subject. But if you have this intersystem crossing, okay, it's actually related to the energy level that I've shown you just now in the Jablonski diagram. So if we involve intersystem crossing, there is a possibility it change into triplet state. So what happened in triplet state is now the spin is changed. The spin now is similar. It has the same, let's say if it is clockwise, both are clockwise, anti-clockwise, anti-clockwise. So the spin is changed. But if it is singlet state, it will not involve any spin change, but triplet state, it involves spin change. So with this, it will trigger, it's not just fluorescent, it will trigger phosphorescence. And with this, there is energy transfer from the process of excited the triplet state. And then the whole thing, it will produce the ROS, the singlet oxygen ROS, and this is the one that kill the cell. Okay, so well, if you want to know more, you can click the YouTube link here. But I think this is something new to me and to you as well. All this while we talk about chemical drugs that can kill cancer cell, but light seems to have can also be a treatment to cancer cell. Okay, so by producing from the reaction of the photosensitizer, the excited in triplet state, okay, end up you have a singlet oxygen, reactive oxygen, what is it called? Reactive oxygen species, and this can kill the cell. So I'm not so sure the application of how it is applied on cancer patient. I honestly, I just learned about this. All right. So it's good to know apart from other treatment in cancer cell. So what involved in this? You need to have photosensitizers. So I've shown you the porphyrin compound. There are other compounds involved that can be used as photosensitizer. And of course, the excitation of photosensitizer in the end will trigger the reactive oxygen species. Okay, singlet oxygen, radicals, hydroxyl radicals. So radicals are actually also produced. So we are always afraid of radicals, but they can be used to kill cancer cell. So the excited reacts with oxygen to produce, okay, and then it can have cellular damage, particularly if you want to target cancer cell, right? So very interesting to listen to the talk. Yeah, very difficult to understand all the terms, spin state, single state, triplet states, but yeah, you're not doing examination. You can just open any other resources to understand that. Yeah, just be curious. It's good to know a lot of things. All right, so I have shown you the structure of photosynthesizers, sensitizers, and explain to you why they are photosensitized because of the delocalized electron. Okay, this is what we call as conjugated double bond. It is spaced between with single bond. Okay, you can see it is spaced with single bond, another single bond. So in between the double bond, there is a single bond. So that is why it is called conjugated. And last one, I think this is the last one, is for you to understand. From the beginning, I mentioned about enthalpy, okay, of reaction. So whenever that we need to have a chemical reaction, most of the time we provide heat, okay. It is not common for the reaction to just happen spontaneously, but at least a minimum of heat needs to be supplied. So for thermochemical reaction, it involves heat, yeah, absorption, the supply of heat, or the reaction itself can be thermodynamic, can be heat absorb or heat release. Yeah. So the reaction, this one I don't want to discuss in detail because you should learn in thermodynamic before. But for photochemical is different. It does not involve heat, but the energy is given through light, through photon. So the presence of light is a primary requirement for the reaction to take place. Temperature has little effect, okay, very little effect on the rate of photochemical reaction. So the free energy change for photochemical spontaneous reaction may be positive or negative. All right, so for thermochemical reaction, the free energy, Gibbs free energy, has to be negative. If not, then the reaction mostly it is not spontaneous. Okay, there's a lot of other factors for spontaneous reaction. It requires certain temperatures and certain calculation to make sure that the negative delta G is negative. Okay, so these are the characteristics of photochemical versus thermochemical. So why is photochemistry considered sustainable chemistry? Because light is considered a reagent involved in the indirectly in the chemical reactions. So it aligns with green and sustainable chemistry because it can reduce our dependency on traditional reagents, chemical reagents. And therefore, we can minimize the usage of hazardous reagents. There's a lot of reagents if we need to do chemical reactions, normal chemical reactions. So by replacing it with lights, there's some reaction that can be done. Okay, photocatalyst. Remember the TiO2 just now, the titanium dioxide? So it can enhance the photochemical reaction. So this is, and the photocatalyst can be, not to say regenerate, we can use it back. We can recycle the usage of photocatalyst. So it is not gone. It is not based on single use. You can use it back. All right, this one I don't know, forbidden reaction. The photochemical reaction offer high selectivity, enable accurate control of specific chemical bonds. I think it's just due to the quantization just now because specific energy is required for the reaction to happen. So that it might give a better selectivity. But the challenges, of course, green photochemistry faces challenges, of course, low efficiency in terms of yield. It is quite time consuming, okay? Unless you are working with artificial light, if we depend on sun, then it's a bit difficult. So we can use artificial UV, but it is still quite slow. The photochemical reaction itself is actually quite slow. Photocatalyst just now, even though it can be reused, but there is degradation, meaning that the capacity, the performance actually getting low every time it is being used, right? It might be expensive because the photocatalyst is using some of it quite rare earth, okay, rare element sometimes. It is a complex reaction pathway. So if you look at photodynamic just now, it seems complex, how the ROS is triggered, produced. Energy requirements, yeah, it is requires specific wavelength because of the quantization of energy. So this also can be difficult because let's say you are using artificial light, so you must use specific wavelength. You cannot just use any UV light with any wavelength. And there are some possible of photocatalyst materials that produce waste, okay, meaning because they are metals. All right, this one, control over reaction products. I think both, if you just normal reaction or photochemical reaction, they are both producing, have some difficulty in terms of selectivity. Okay, so I think that's it for photochemical reaction. So I would like to share, just a moment, yeah. About the, where is it? Your assignment, yeah. Okay. Okay. So I know that some of you are finishing your short projects, but just remember that it is better to have higher portion of evaluation in coursework, meaning that assignment and all that, rather than having it in your final exams. Because final exam usually is difficult and it's difficult to get good marks, okay? So if you can do the coursework, the marks almost guaranteed. Okay, the marks are almost guaranteed. Okay, so I hope that you can see the Putra Blast. Okay, so this is Dr. Ely's assignment. Okay, because I'm teaching the second one and after Dr. Halim, so it's a bit late, I understand. All right, so I think you knew from the beginning that all the subjects have 70% coursework and 30% final. Okay, so it cannot be just like the whole 70% for a single assignment. That cannot be. So your assignment from me, because 30% is from Dr. Ely, okay, and 40% is from me. So this one is based on tutorial like, okay. So you will answer questions just like answering tutorial, a very short question you answer. There's a lot because it covers 3 topics, which is extraction technique, green extraction, photochemistry, and green energy. So of course, there's a lot of questions, but remember it gives the weightage of 20%. And answering this tutorial is now, I think it's very easy for you because you can use ChatGPT. And of course, I understand that, but the most important for me is the effort that you do, because when you search the information, that's when you learn, okay, by trying to find the information. Okay, so that is the effort. 20% answering question, and from there you learn, right? So the submission of assignment 1, as usual, I'll be giving you some dates. So here I put in July, 5th of July, but if you need extended, some extension, then of course you can ask me, okay? Right, the second one, okay, because we need to have individual and group work. Why? Because we need to have group work, because in evaluation of all the subjects, okay, whether you are undergraduates or postgraduates, it is a must for us to observe your communications, your work together ability. But I believe this is something that you have done this before, okay? So previously, it is more difficult. I know that you have to take the, you have taken statistic with me, statistic and chemometric. I asked you to record meetings and all that. And then you need to study the case study, and that was tough. Yeah, I understand that. But this one is not that difficult. So there are 4 groups. There are 14 of you. So so we will do the room separation so that you can, or I think some of you preferred, because some of you are different batch. So you might need to have you to form your own group. So I'll leave it to you after this lecture. You can form your own group, but there are 4 titles. So it should be 4 for each group. Sorry, 3, 4, 14, right? 4, 3, probably some will have 4 in their groups, yeah, right? So it depends on you. You will divide into 4 groups, and titles are shown below. So it's not really that difficult. So for example, green extraction technique, identify and discuss at least 3 challenges of barriers. So when you have this kind, there are sort of a few things that you have to explain. The barriers, potential solutions to the barriers, speculate future of green extraction. Okay, so you can just divide that into with your group members. Okay, and then this one, what emerging trends? Okay, so you can divide that. So I don't need you to record the meeting or whatsoever, but what you need to submit or do is you record your presentation. Okay, I hope that you don't present you don't have a single presentation separately. I mean, you can do the presentation separately, but somebody need to combine them. Okay, somebody need to combine them. So one group, one presentation, but you can have multiple presentation in that video. Okay, and you need to also send to me the slides that you presented in that video. Okay, so are you clear with the second assignment? Questions? Everybody?
It's
Prof, I have a
Yeah.
question.
Sorry. Who's
Sorry,
asking?
Tiffany.
Yeah, all right, Tiffany.
Is there have some maximum time for the presentation?
I don't usually post maximum time. Okay, it's up to you. Okay, it's up to you.
Okay, thank
Because
you, teacher.
some of you talk slow, some of you talk very fast. So I don't want to limit because I'm the one who's going to evaluate. So I don't mind long or short. Okay. Okay. As long as you deliver. All right. Any more questions? Probably someone else I heard.
No, Prof. I just said it's clear. And
Yeah.
can you choose the topic and post it on the group so we don't,
Yeah. Okay.
Okay. All right. Thanks.
So on the division of your groups, because I know that some of you are different batch, you have your preference. So please do divide yourself. Okay. So if I divide, you might have like somebody is working, somebody is full-time. You might have some difficulties. All right. So I will post this. Actually, you can, well, let's talk, let's discuss in the WhatsApp. Okay. So this is the link for assignment, submission of assignment 2. So I'm giving you a lot of time, okay? And your final exam will be on 12, if I'm not mistaken, okay, 12th of July. But then it's an open book exam, yeah? So some of you has taken my sensor technology exam. So you know how it is, an open book exam. So open book exam is I give the questions, I upload the question at 8 a.m. in the morning, and you have to send before 12 midnight. Okay. But again, due to the ChatGPT and all that, so please don't just cut and paste. At least do some narrative by your own. I hope you understand. Narrative means that you get the facts, but you manage it, you write, in a better essay. So that don't just cut or copy paste, obviously. Okay. Yes.
That means if we use ChatGPT, not to take the information, just like we have already the information, but we need to use ChatGPT to organize it like that.
Yeah, for information. I mean, you need to find information.
We bring the information from previous studies or something like that. So we just use ChatGPT to organize the answers. Is it okay that, or we need to?
The key here is, okay, the key here is not to 100% do copy and paste.
It's not about,
yeah.
It's not about
Okay.
copy paste. I mean, we have already the information for the answer.
Yeah.
We just use it to organize to the answer.
Okay, let me give an idea. For example, one of these is an exam question. Investigate the role of solvent in the extraction process. For example, okay, when you search for ChatGPT, of course you copy this statement and then you put it there, and then it gives out the answer. Okay, so what I meant is you read it, you write it back, yeah, in the narrative. In a proper narrative by your own. Okay. But the information is there. I understand. There is open book exam. Okay. Okay, Ahmed. Okay. So somebody asked about the numbers. Yeah, it's gonna be like 3 to 4 because there are 14 of you. Right? Okay. Question before we end? I think it's quite clear, right? Okay, right? So don't be too stressful. Okay, so you are approaching your finishing line. Yeah. All right, so I think everybody should be all right. If you, I don't know how to, I suppose is first come, first serve. If you form your group as soon as possible and then you bid for the title, I will give to the first person, whichever the titles from here. This is available in Putra Blast. Yeah?
Sorry, I just have one question.
Yeah.
Assignment 1, you said the due date is flexible. So what is the longest that you can extend it to?
Okay. The rule is we have to submit the marks, okay? Usually is around 10 days after final exam. So if your final exam is 12 July, so you just plus 10. That's the maximum that I can go.
Okay.
All right.
Thanks.
Okay. So form a group, bid the title. Whoever bid first, then that's yours. Okay. All right. Okay. So I think that's all. Thank you, everybody. I'll be sharing the recorded one, this recorded lecture. Okay. Bye-bye.
Thank you, Prof.
Bye.
Thank you, Prof. Thank you, Prof.